ever know? Currently, 99% of data traffic which crossing oceans is carried by undersea cable. Have you ever feel? Modern military weapons is an awesome design? Actually, do you know? The internet connection that we usually use in our daily life is same as the data transmission system in certain modern military. There is at least 95% of voice and internet traffic travels through about 300 transoceanic fiber optic cables along the seabed. All this traffic including military transmissions and more than 4 trillion per year in financial transaction. Let's have a look on some interesting image and motion before go more details. This show the transformation of transoceanic fiber transmission. The development of this technology is being bring out and make changes to the world. What the effect after stars apply this technology? The effect range start from simple human daily life until the seriousness case about country military decision. All this improvement tell us that the research and development on transoceanic fiber transmission have never been stopped and is continuously improving.
Hello, everyone. Today, I will bring all of you go back to the early 1850 to learn about transatlantic telegraph cable.
Did you know? What is the relationship between transoceanic fiber transmission and transatlantic telegraph cable? Sure, let's start our lesson. Transatlantic telegraph cable is the transoceanic transmission cable that occurs in the middle of 19th century. What's about the history of transatlantic telegraph cable? It is an undersea cable running under the Atlantic Ocean used for telegraph communication. The first was laid across the floor of the Atlantic from Telegraph Field, Foyle Rum Bay, Valentia Island in Western Ireland to Hearts' Content in Eastern Newfoundland. By who? Cyrus Westfield, Atlantic Telegraph Company. What is the cable name? TAT1, TAT1. What materials involve in the design? First, Cooper conductors insulated and waterproofed with natural materials, hemp rope, and gutta percha. Second, armored with steel wire. Where is the cable route involved? First is for east-west traffic. Second is for west-east call. What is inside the cable? Let's look on the design description. The core of each cable. 1. Single coaxial cable with solid copper center conductor. 2. Polyethylene dielectric. 3. Multiple shield of copper tape. Provide return path of the signal and protected the cable from marine worms. For the whole cable. 1. Wrapped in cloth tape. 2. Jute impregnated with waterproofing. 3. In steels for armoring. The cable design include flexible inline repeaters, which provide 65 decibels of gain and 144 kHz bandwidth, which can boost signal at 69 km intervals. Each 2.5 meters used 3 vacuum tubes that can withstand pressure at 8,000 meters under the sea. The significant 1. Transmit billions of words per second. 2. Allowing a speed of communication. Summary. Early 1850s, telegraph networks had connected most population centers on either side of the Atlantic. 1856, Field had set up the Atlantic Telegraph Company, with investors including both businessmen and the U.S. and British governments. 1858, messages could be sent between Europe and North America in minutes, rather than day, but within weeks, the cable failed, and the connection was lost. 1864, manufacture and improve the cable. 1865, 2,600 miles of new cable were ready. The Great Eastern sailed from Ireland westwards, carrying the full length of cable. But more than halfway through the journey, the cable snapped and was lost on the ocean floor. 1866. The Great Eastern set sail again on the 13th of July. At end of August, they managed to hook the end of the cable successfully, and bring it aboard. 1902, a telegraph cable from Canada to New Zealand, completed a network that encircled the globe. 1956, TAT-1 went into service. It provided 36 channels, 35 phone channels with 4 kHz of bandwidth, with 22 telegraph circuit on the 36th channel. Improvements in carrier technology, and narrowing the bandwidth to 3 kHz, eventually brought the cable up to 51 channels. 1957, all of the TAT have been retired except TAT-14. There is the summary for this section. Let's proceed to the next. This is about cable structure. Have you heard about submarine cable? A submarine communication cable is a link laid on the ocean bed between land-based stations to convey media transmission flag crosswise over stretches of sea and ocean. Have you ever think, what cable used in undersea? What have in submarine cable? Let's see the cable structure to understand more details. What means optical fiber? To transmit light between the two ends of the fiber and find wide usage in fiber optic communications. Why petroleum jelly is needed? It reduces the friction of distance during various lubrication and keep larger cable firmly. Purpose of having copper or aluminium tube. Active cable that get from extreme linked in the underwater internet cable. The lighter optical fiber boosted 50 or more mile to amplify the signal. Polycarbonate, aluminum, water barrier, stranded steel, mylar and polyethylene is the last layer that important for process of laying the cable under the sea from special trawler ship. Let's understand more details about the mechanic design in cables. Let's see what challenges that submarine cable have to overcome. First, cable installation is slow, expensive work. Second, sharks are trying to eat the internet cable. Submarine cables difficult to repair, but after 150 years, we got solution. Let's see the network destruction. Hope that you are more clear about the cable structure. Thank you for listening.